Here's another energy problem that may seem very complicated at the beginning, but once you do a few of these, it actually becomes pretty straightforward. This is also another problem that would be impossible to solve using just our motion equations and Newton's laws. And here is the problem. We're going to have a spring. It's compressed. It's basically going to push this cart with this one little passenger. So right now nothing's moving at the beginning. Then the spring is going to push, accelerate the cart. The cart's going to move. No friction. Where's black? There. All right. So basically, again, I don't want to deal with friction yet. It's coming, but no friction. So friction is negligible. So the car is going to basically rocket along. Well, not rocket, but it's going to speed along. Then it's going to do this loop-de-loop and come back, and off it goes. And what I want to know is, how fast is the cart going here at the top? And we can see that basically I'm going center of mass, kind of there's kind of like the center of mass of everything there is 15 meters above the ground. That's what I want to know. And let's call this, all right, so typically my thing, I'm going to call everything going on here at A, and so this is kind of like B. And so I want to know basically what is VB? What is the speed at B? Okay. What's our system? Because on the AP exam, they may ask you to justify what goes in your system. So where should I put that? I'm going to put that down here. Okay, system. Well, whatever's moving, and obviously it's going to be the cart and the passenger here, it needs to go in our system. So I'm just going to call it cart. Assume that includes the passenger. Now, the spring. Well, let's go to the earth. Okay, let's do the earth thing. Is your object changing height? Absolutely. Do we want to think of gravity as an external force? Absolutely not. We just want to think of energy transformations, not gravity doing work. Because, look, gravity would be doing negative work here, positive. Don't want to go there. So basically, we're just include the entire earth. Talked about that in my previous video. The entire earth is going to go in there because it's the earth that creates the gravity field that stores the potential energy. Okay, then, do we want to include the spring? I don't really care whether you do or you don't. I'm going to go ahead and include it because I want to think of the energy in the spring in our system transforming into the kinetic energy of the cart. If you don't want to include the spring, that's fine. But then you have to say that the spring does work on the cart. So whether you want to think of the spring as being external and doing work, transferring its energy, or if you want to think of, oh no, I want the spring in my system, therefore it's not a transfer, it's a transformation. Hopefully you can see it doesn't matter as long as you account for the fact that the energy is going to go from the spring into the kinetic energy of the cart. I'm going to go ahead and include it because I want this to be, so all we're going to do is we're going to have a closed system and we're going to have just energy transformations. There's going to be no work in this. Okay, so since there's no work, now my statement of conservation of energy, I don't know why I'm doing it down here. I'll do my solution over here. Since there's no work, then the energy in my system, my cart, earth, spring system at A, has to exactly match the energy in my cart, spring, still there, spring, earth system at B. Okay, so now let's just solve it. Okay, so what are the forms of energy present in my system at A? Well, once again, so now what's the lowest this cart's going to go? And I'm going to say basically it's at H equals 0 right now. So if I take mgh as my gravitational potential energy, and I say, oh, it's at H equals 0, so there's no gravitational potential energy at A. It's at the lowest point it's going to go. Okay, so there's none of that. And then, is there any motion? No, there's no motion. So there's no kinetic energy that's going to go here. Okay, so what's the form of energy? Spring energy, okay? You say, well, how much energy is in the spring? Well, take a look. If you know the spring constant, and you know the amount of squish, you know that. That's something you can quantify. So don't worry, we're not going to worry about that yet, but we know that. It's very knowable. Okay, so there's a certain amount of spring energy at A, and that's all our energy in our system at A. Then, what do we have present at B? Well, the spring, if we were to look back when the spring is sprung, right? So it's going to be back at its natural state. So there's going to be no spring energy. The cart is moving, so there's going to be kinetic energy at B, plus it's now elevated above its low point. So it's going to have some gravitational potential energy at B. Okay, now I thought it was supposed to be finding the speed. Where is that in here? Well, that's in here, right? This is the 1/2 mv squared. So this, we're going to kind of blast these and we'll expand them into their equations. And we'll see, okay, the v is in this guy. All right, let's go ahead and just, boy, did we even need to know the mass? Yes, we did need to know the mass. Never mind. All right, so basically this is going to be 1/2 k times the amount of squish. And this is all happening at A. Should I put an A there? Sure. Okay, and then this is going to be 1/2 m times the speed at B squared. That's our guy. Plus mgh at B. Okay, so a little algebra. You already see we can solve this. I'm not going to take too much more time here because, but basically if I get rid of that, and I put a 2 in front of there, and let's just see, do I know K? Yes. Do I know the amount of squish? Absolutely. Do I know the mass of the cart? Yes. Do I know, yes, the mass of the cart? Do I know the gravity field strength? Yes. Do I know the height? So basically, you can just solve for it, okay? So I think I'm not even going to solve for it because I think you can do that, right? You're just going to plug everything in, and you're going to get, well, it's okay, I'll write it out here. Let's just go ahead and write it out without the numbers. So the speed at B equals, okay, so we're square root. Okay, what do we need to do? We need to push that over to there. So we're going to have k x squared, and that's happening at A, divided by, you should do this yourself, but just as, okay, and I think I'm doing this correctly, minus 2gh at B. Now, this is never something you would try to memorize. No, no, no. This is, if you're going to memorize it, this is not really memorized. This is the flow, right? And then this is just the algebra that gets you to the answer. Okay, I believe the answer, if I set it up correctly, was going to be around 10 meters per second. Something around 10 meters per second. Okay, there's one more example. Hopefully they're getting a little easier.